Today we're going to save and share traces using the Moore CT100B. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment, and never connect to live equipment. Scanning and saving traces is easy with the CT100B, and this video will show you the process of scanning a cable, saving a trace, and transferring that trace from your CT100B to your computer through your network or using a USB drive. First, we're going to connect a cable to scan. To make sure I capture the entire cable, we'll use the CT100B's AutoFit function to ensure the TDR waveform includes the start and end of the cable. Here on the screen, we have the beginning of the cable, the connections here in the middle, and the end of the cable where the end is open. We're going to briefly discuss the different CT100B resolution modes as they apply to the TDR waveform and the respective scans. After that, I'm going to demonstrate two scan modes and review the differences once the scans are created. We'll demonstrate how to save and archive the data. Sample resolution will affect the detail of the scan. Sample resolutions are screen, normal, and fixed. Screen resolution is by far the fastest and is adequate for many routine cable testing tasks. At large horizontal scans, however, the resolution is low and small faults may be undetectable or at least underestimated. This is because there may be too few samples in the region of the fault for the fault to be reliably identified on the trace. For example, if a 1,000-foot cable is displayed on the screen, there is only one measurement about every 2 feet. However, if I zoom in on something specific, that resolution goes up, and it goes back down as I zoom out. That's because the resolution is limited to how many pixels wide the display is. Each pixel is a data point. For the normal setting, the sample resolution setting is chosen to match the cable length setting for good compromise of detail and speed. Pre-selected options are available based on the length of the cable being tested. For short-length cable settings, the resolution is 5.34 picoseconds, basically less than a millimeter, and is good for short runs under 300 feet. For medium length, resolution is at 17.5 picoseconds, roughly about every 2 millimeters, and medium is for cable lengths under 1,500 feet. For long cable lengths, resolution is 49.6 picoseconds, about every 5 millimeters. And this is for long cable runs over 1,500 feet up to about 6,000 feet, depending on the cable type. Fixed resolution is a set sample resolution manually selected using the M function knob, and it stays fixed regardless of the screen's horizontal scale. So whether I'm zoomed in tightly or zoomed out at 1,000 feet, it will stay at that set resolution. To scan a cable, we're going to press the scan button, and then we're going to select between cursor or snapshot from the options here. Cursor will scan between the cursor selected by the operator, and snapshot will save a scan of the cable visible on the screen. And for this first scan, we're going to demonstrate snapshot. Start scan will lock the on-screen trace in place and display it in red. I can now save and name this trace by pressing save. You can use the on-screen keyboard function to name the trace, or you can attach a USB keyboard. Now we can see the saved trace on the screen with the name that we gave it. Now we're going to save an additional snapshot, this time at the highest resolution possible. We're going to press the menu button. We're going to select fixed from the resolution options here. We'll just cycle through, and we're going to leave it at 0.76 picoseconds. Now we're going to press scan, and we're going to leave it as snapshot, and start scan. And like before, it turns it red, locking the trace in place. Press save, and we're going to name this one High 76 Res Full Screen, and then select OK, and there we have it saved on our screen. To scan just a section of the cable, there are two ways. You can zoom in on just that portion and do snapshot like we just did. Or you can get more specific with the cursor option. Align the cursors with the area to be scanned and select cursor from the options, then select Start Scan. You will notice that just the area between the cursors was scanned and is showing red on the display. We can now save and name this by pressing Save and then naming it like we did before. These traces are now saved to the CT100B and can be recalled anytime through the File menu. If your CT100B is connected to your network, you can use the tools within the CT100B's internal web server and our CT Viewer software. If it's not practical to connect to your network, these files can be saved and transferred through USB. Simply connect a USB drive to the CT100B, press File, select Cable Scan Records, and select the desired files to be transferred to USB. You can select one or select all. Files can then be transferred to a computer, emailed, and even dropped into CT Viewer for easy evaluation anywhere. And now let's see how these compare on CT Viewer. With the CT100B connected to the network, I simply click Open Tester, select the save files, and here they are on my screen. I'm going to separate these out so we can see them individually. As I hover with the cursor over each of these traces, it gives us information on each trace. Notice the number of points. 750 for a screen resolution trace. Nearly 3,000 for just the connector we scanned between the cursors at full resolution. And over 38,000 for the complete trace set at the highest resolution. And now we're going to show CT Viewer with points. And when I talk about points, CT Viewer can show us the actual points. Each dot is a data point recorded by the CT100B. And notice the difference in the scans between our screen resolution, how far apart they are, and fixed resolution at the 0.76 picoseconds. It's nearly a continuous line until we zoom in even further and we can see these individual dots that make up the trace. And for the normal resolution scan that I mentioned earlier, I've got some other samples that I took before. We can see the difference between normal long, normal medium, and here at normal short. You can still see there's a difference between normal short and the full resolution at 0.76 picoseconds. And there you have it, scanning and saving traces, using the More CT100B and analyzing and archiving with our CT Viewer software. For more updates, subscribe to our YouTube channel or check out our website at moretm.com. Or feel free to give us a call or shoot us an email. And we'll see you next time.